Configure a Raspberry Pi and connect it to the IBM Cloud. This video works for Raspberry Pi 2 Model B or Raspberry Pi 3 Model B. You just received your Raspberry Pi and you want to connect it to the cloud. In this video, you will use Windows 7 to install the Raspbian OS on an SD micro card. You will then configure the Raspberry Pi with the Raspbian OS. Using Node-RED, an open-source development environment which is pre-installed on your Raspberry Pi, you will create an application which reads the CPU temperature of your device, but more importantly, reports this data on the IBM Cloud. You will see how to access the IBM Cloud platform and visualize the data you are sending. Let's get started. For this task, you will need your Raspberry Pi, an SD micro card with adapter which will host the OS for the Pi, an Ethernet cable to connect to the Internet. You could also use wireless connection, but that requires a little more configuration on your Pi. A monitor and an HDMI cable to connect to the Pi, a USB keyboard and mouse, a computer to configure the SD card, and power supply for everything. The first step is to install the Raspbian OS on an SD micro card. This work will be done on the computer. To do this, you need to download the latest Raspbian and a tool to help you write the image on the SD micro. I am using Win32 Imager. Uncompress the image using 7-zip, for example, and install Win32 Disk Imager. Okay, let's get the OS on the SD card. Put the SD micro in an SD adapter and plug it in the SD card port on your computer. If you don't have an SD port, use a USB adapter. My SD card is in my D drive. Start Win32 Disk Imager. Point it to the Raspbian image you extracted and tell it which drive hosts your SD card. Remember that this operation will overwrite the card, so make sure you're using the correct drive. Do not click Read because that will take the image from your SD card and overwrite the Raspbian image. Click Write. This will replace the SD card content with the image specified. In this case, the latest Raspbian. This process takes a few minutes, but eventually, if all goes well, a success message is displayed. This is the file system on the SD card once the install is complete. Once the SD card is imaged, you are ready to configure the Raspberry Pi. I connected my Raspberry Pi to the screen using an HDMI cable and to the Internet using an Ethernet cable. Insert the SD card micro in the Raspberry Pi and power it up. The primary desktop is displayed when boot is complete. Click on the terminal icon to open the terminal window. From the terminal window, start the Raspberry Pi software configuration tool by typing sudo raspi-config and pressing enter. The Raspberry Pi software configuration tool provides a straightforward way to configure your Pi. The expand file system is selected. Press enter to expand the file system. If this is successful, you will get a confirmation message. Press enter to continue. Using the up-down arrow keys, select the Change User Password option and change your password from the default. Use the internalization options to set your original language. Use the spacebar to select one or more languages. Set the default locale. Set the time zone. From the advanced options, set the host name for your Pi. It is a good idea to also enable I2C, which is a multi-device bus used to connect devices like SenseHAT to your Pi. Reboot the device so these changes can take effect. Once the device boots, log in with your new credentials. Update the Pi firmware and reboot again. Then, use the update command to check which updates are available for your Pi. Use the upgrade command to download and install updates after the update. and the auto remove command to clean up old items no longer needed. You just completed the basic configuration. Let's move on to the fun part. Use the clear command to get a clean screen. Get the IP address of the device by using the hostname-i command. You will need this when working in Node-RED. Send a command to your Pi to see its temperature. You will use this command again within Node-RED. Notice the output format of the command. Start Node-RED. Soon the device is connected. To create the Node-RED program, you could work directly on your Pi using a browser like iceweasel. Alternatively, you can use a web browser on your desktop and connect to your device. In your web browser on your computer, type the IP address of your Pi, :1880. This is the port that Node-RED listens to. Node-RED comes with some nodes that connect to the IoT platform, like in the input section, Watson IoT, and the output section, Watson IoT. Let's build the flow. From the advanced section, drag the exec node in the flow. In the info tab on the right, notice the details of this node. Double-click on the node to edit it. In the command section, add the vcgen-c command, uncheck the MST payload, add the measure_temp parameter, and name the node. Example, get CPU temp. This is the name that will appear in the flow. Press OK and close the context window. Add a debug node from the output section to display the result of the exec node in the debug window. Add an inject node from the input section to tell the system when to take the temperature. Connect the flow. Deploy the runtime. Click on the Debug tab on the right. Click on the Inject node and notice the message in the Debug tab. To get a message on the debug window, you have to assure that the debug node is active. This is great. Now let's output this to the cloud. From the output section, drag the Watson IoT node onto the flow. In the Info tab, Node-RED describes the way Watson expects the data, so we have to change a string to the format Watson wants. From the Function section, drag the function node onto the flow. Double-click to edit the node. Write some JavaScript to take the message object and create a payload which prunes the incoming payload, leaving only the number. Once it reformats the message, it returns it, sending it to the next node. Let's connect this function node to the debug to see what it looks like. I am not limited to one input and output from the nodes. Simply connect what you need. Redeploy for the changes to take effect. Click on the Inject node. Notice that the format is what we need it to be. Now connect the function to the Watson IoT node, which will send this output to the cloud. And to make the data more dramatic, let's send this data every 3 seconds. Redeploy. Double-click the Watson IoT node and click on this button to connect it to the cloud. Congratulations! You are looking at your device's CPU temperature reported on the cloud every 3 seconds. You just saw how easy it is to use services provided by the IBM Watson IoT Platform to connect to the cloud. Now register for IBM Bluemix to access the IoT Platform services within Bluemix and rapidly compose and extend applications that take advantage of data and analytics from your connected devices and sensors. I hope you found this useful. Have fun exploring.